Greetings and welcome to our COVID-19 Returning to Work presentation, focusing on research park environments. My name is Larry Barton. I'm an architect and president of Strang Architects, Engineers, Interiors, and Planners. With me today is Erica Ostendorf-Mullins, Senior Vice President and Director of Interior Design. Strang is an integrated design and planning firm with in-house engineering. We have a strong focus in sustainability, health, and wellness. It's a design culture we call design synchronicity. Our Madison, Wisconsin office, shown in the picture, is LEED Gold certified and is on pace to be the first well-certified building in the state of Wisconsin. This extra attention to wellness within the workplace has been beneficial to our handling of COVID-19 as we brought back our own staff into the workplace. For the past 6 months, we've been providing free consulting and presentations to organizations such as yours who need assistance with their return to work strategies. We specialize in the design of research parks and other science facilities, and we've become quite familiar with the special requirements of these buildings and the labs within them. Our agenda is arranged around OSHA's primary recommendations for providing a safe work environment in the COVID-19 era. But before we discuss protective controls, it's important to understand what it is we're protecting against. The CDC has made this rather clear. It's the spread of respiratory droplets produced from coughs, sneezes, or talking. OSHA, in turn, has issued statements about preventative measures a company can take to reduce the risk, and they prioritize these from most effective to least effective. You will see that the effectiveness tends to be inversely proportional to the level of human interaction required.
Based on the hierarchy of controls, the most effective action you can take is simply removing the hazard. Recognizing that people are the primary hazard, you can remove the hazard by asking people to stay home. Keeping your workforce at home might not be effective for your organization. When you've decided to bring people back for the first time, or you're increasing the workforce in the office, there are some risk factors to consider, including personal health challenges, the type of work that is done, which can be considered high, medium, or low risk based on the interaction with other people and the public, and the environment at which you are asking people to return to. Once you've decided to bring employees back, select the individuals who will be returning to the office, either based on job function or by requesting volunteers. Determine how you want people to occupy the space. Will they be returning to the office in a hybrid fashion and splitting their time between home and the office, or returning to the office 100% of the time? If you're looking at a hybrid model, staggering days in and out of the workplace can reduce capacity and maintain social distancing. Some options to consider are alternate days in the office, a day in the office and a day home, or a 2-week 10-4 cycle, where employees are in the office 4 days a week and then are at home for 10 days. If equal access to the workplace is needed, the workday can be expanded into shifts. By creating a morning and afternoon shift, it would limit the amount of people in your space at one time while allowing a full day access to the workplace. There's no one-size-fits-all approach to this. Every organization must consider the appropriate quantity and worker selection to bring back into the environment, as well as the pace at which to do so.
OSHA suggests the second most effective strategy is engineered controls. Engineered controls are not highly dependent upon human interaction. Once put in place, engineered controls typically function automatically with predictable results. In terms of reducing the risk of virus spread, HVAC systems play a significant role. The diagram above depicts a traditional HVAC system, which you might find in a range of buildings within your research parks. This could include daycare centers, restaurants, hotels, office buildings, and research facilities. The HVAC system ventilates and conditions the air within the work environment. There are several adjustments that can be made to an existing HVAC system to provide added protection against the virus. First, you should make sure that the existing system is working the way it was intended. A simple retro-commissioning accomplishes this by confirming all systems are functioning properly and receiving the intended amounts of conditioned air. Next, you can introduce a higher percentage of outside air into the system. This reduces the level of recirculated air which may have picked up contaminants. You can also increase the ventilation rate, but first review with a qualified HVAC engineer. This is to confirm your existing system is sized to handle the conditioning of the additional outside air. You should also consider upgrading the HVAC system filters to a higher MERV rating if the system's sized to handle them. The diagram on the right of this slide demonstrates how much more effective a MERV 13 filter is in comparison to a more common MERV 8, which one might find in a standard office environment. Your lab spaces most likely already utilize highly efficient filtration, which are already matched to your HVAC systems. Increasing the MERV rating of your filters places added stress on your HVAC system fans and ductwork. So you should always consult with an HVAC specialist or engineer before upgrading your filters. If humidity control is available in your HVAC system, it can be set to an optimal range. The chart above shows that a range of 30% to 60% is optimal for human comfort and health, but the higher end of that range is best for virus protection. Drier air in the winter, teamed with more people spending time indoors, is one of the reasons flu and other viruses tend to increase during this time of the year. In addition to simple HVAC adjustments, certain additive retrofits are also available. One additive option is the installation of ultraviolet lights within the air handling unit and ductwork. This is a relatively easy retrofit and serves to disinfect the air as it passes through the lights. This system treats the air that is introduced to a space but does not protect against direct person-to-person transfer within the space, which occurs throughout the workday. Another technology that can be retrofitted into an existing HVAC system is bipolar ionization. Ionization rods are placed within the airflow of your air handling unit after the filters. Microscopic airborne virus pathogens, too small to be captured by the filter, then pass through the bipolar ionization rods. The process causes these ions to become charged and join together and become larger in mass. They're also neutralized in this process, rendering them harmless. The ionized air, when delivered to the occupied space, continues to neutralize viruses within the room, reaching 99% removal after 45 minutes, according to recent test results. Air movement within the occupied space improves the neutralization. Therefore, increased ventilation or ceiling fans can improve the results even further. The neutralized ions that remain are now larger in mass and can be captured by the filters in the return air system. Thus, the process repeats itself throughout the day with each air change. Research facilities inherently have complex HVAC systems with a wide range of requirements. Engineered controls for the labs are often much different from the office spaces. The types of research occurring in the labs impact the types of HVAC systems utilized. So random adjustments or additive measures intended to protect against COVID-19 may unintentionally impact the experiments occurring in the space. It's especially important that both researchers and qualified HVAC engineers work together before making any modifications to lab environments. Certain trade-offs may be necessary to optimize building systems for added protection against virus spread. Although this may increase the amount of energy used and the associated energy bill, these temporary measures can protect your staff until the threat of the virus diminishes.
The next item on the hierarchy of controls is administrative controls. Administrative controls in the case of COVID is largely creating an environment where social distancing can take place. As Larry mentioned, HVAC is different between labs and the office space, so is social distancing. Labs may already have some safety precautions in place. The work area is spacious and less dense than the office environment, and PPE may already be required, such as gowning, coats, gloves, masks, etc. And there's more opportunities for hand washing. Typically, social distancing within lab environments is generally as simple as limiting the number of people working in a lab to reduce close proximity. The time between the lab and office is typically split. The percentage varies greatly based on company and industry. Most of our clients are striking a balance by allowing access to the labs, but all additional work is completed at home to the extent possible. This diagram illustrates a possible density difference between a lab and an office environment. Additional precautions are needed in dense office settings. Within those dense office areas, social distancing can be achieved at the workstation with a quick study of the space. In this example, a 6-foot diameter personal zone was created at the primary workplace at the workstation, which is the computer. And then we studied how that zone shifts as someone moves to the extent of their workstation. Once you understand the density of workers to workstations, a full study of the office can be completed. The example shows social distancing concepts applied across a typical office floor plan. In this case, 50% of the workstations can be occupied at one time, and that is shown in green. This diagram can then be used to work out alternating occupancies or shifts. Another thing to consider is at this time is circulation. If you have a high density of people in your space with tight aisleways, you might suggest some areas to have one-way circulation. Moving beyond the areas where work happens, administrative controls will also need to be extended to the entrance, reception, and restroom. In the reception area, create a controlled point of entry and establish a check-in procedure for contact tracing and temperature screening. Consider a shield here. Depending on your business, the front desk worker will most likely encounter the highest number of people at a close range. In the toilet rooms, review circulation to and from the restroom to eliminate cross traffic if possible. Disable electric hand dryers and provide paper towels. If you have a pull to exit door in your restrooms, consider providing paper towel and trash receptacles at the doors. Within kitchen spaces, congestion can be common, especially around the refrigerators, microwaves, sinks, and trash receptacles. This may be an area where you consider adding additional social distancing cues like floor markers. It is also advantageous to keep disinfecting wipes near shared equipment for frequent cleaning. If your organization uses reusable dishware and flatware, consider temporarily switching to recyclable or compostable options. If trash and recycling is located within cabinets, consider switching to hands-free options. Alternate state mandated guidelines may be in place for corporate cafeterias or kitchens where food is being prepped and served. Collaboration and teamwork has long since been the engine for creativity and innovation in organizations worldwide. Social distancing will change the way collaboration occurs, but not prevent it from happening. In these collaboration spaces, follow state guidelines for maximum gathering numbers. Evaluate meeting spaces to determine how many people can safely fit into the space while maintaining proper social distancing. Remove the hazard, in this case that would be extra chairs, and provide safety procedures within these rooms. Alternatively, meeting rooms can also be used as private workspace to get more people back into the office while maintaining social distancing.
Number 4 on OSHA's prioritized list of controls are safe work practices. Hand washing, covering sneezes, not touching your face, staying home when sick, and monitoring temperature are becoming commonplace. Most organizations already have these safety practices in place and have communicated the importance to their employees. Consistent messaging and setting a strong leadership example are what's needed to instill a lasting culture of safety. We recommend enhanced cleaning protocol for high touch areas and equipment within your occupied spaces. Creating a cleaning diagram helps communicate zones and components requiring extra attention. These include things like countertops, appliances, door handles, touchscreen controls, and shared office or lab equipment. Surprising to most, OSHA has listed PPE as the least effective control of those discussed. The only reason wearing a mask is not listed as one of the most effective controls is because people are reluctant to wear them. In terms of personal responsibility, wearing a mask is the one thing that you can fully control as an individual, and it's proven to be effective in reducing the spread of COVID-19. Although initially in short supply, masks are now readily available for use in offices and research environments. There's not much more that needs to be said. Wear your mask.
Certain lessons learned during the pandemic will have led to greater understanding and new possibilities within the workplace and research environments. Many will result in positive change. We should embrace the positive and move forward. So, what's next post pandemic? We are learning that not all work needs to be accomplished within the traditional workplace or lab. We are also learning that greater flexibility is possible with both hours and location. This will lead to improved work-life balance and more nimble workspace. Healthier work environments are not only possible, they will become an expectation. Virtual collaboration will continue to improve as well. In closing, we expect the work environment across all industries to change in many positive ways. It will become more distributed, collaborative, and agile, with a much greater focus on discovery and innovation. University research parks are in an excellent position to lead the way.
We thank you. Our contact information is listed on the screen. We welcome your questions and are happy to be a resource if you'd like to discuss any of these topics further.